Hello out there, Bob Hughes here with JD Squared. Thanks for watching. I want to apologize for some of the noise you might be hearing in the background. I am working in a live factory environment, and for people who have orders on machinery, I'm sure they want this factory building their product. Anyway, this is a project video, and in this particular project, we're going to be utilizing the RC6 Rotary cutter. It can be done on our flatbed rotaries. Either machine doesn't matter, but we're going to be using the RC6 with the automatic tube stabilizer installed in it for this job. And this is what we're going to build. It's a business card holder. And a while back, I had requested submissions by people for us to build things, give us some ideas. And a gentleman named Travis came through. He sent me 3 projects over, and he had built one of these. He already owns another manufacturer's machine. And he basically wanted to know, you know, what were the differences between his machine and this machine, and also the software. So he sent me the pictures, and this is the end result. So without further ado, let's build this thing. Okay, what we have here is the first thing we're going to do is mark the tubing. This is the top tube. And this is where the welder will be placed into 3 columns. Essentially what we did is we transposed the OD of the columns onto this tube right here, and we're using this marker. Now it's just a permanent marker with a little push button. I'm going to go ahead and push the button again to, well, it retracted itself. All right, let's turn on the coolant. I almost forgot. I did mention it makes a difference. Okay, you can hear the clicking of the automatic stabilizer grabbing. Beautiful cut. I actually don't even see any slag. Another huge advantage of through coolant is it's a cold part. You can see the cut right there, cut quality. Now currently, just to give you a heads up, we're working on smart nesting. So that Camelot will automatically rotate all the parts and bring them together in the most efficient manner for the tube usage. That's something to look forward to in the very near future. You can see the automatic lifter, well, maybe you can't see, is underneath where we're cutting. It will automatically retract whenever the head comes into that area. We're going to be doing a lot of projects, so if you're interested, go ahead and subscribe. I think over the next 2 weeks, we're probably going to do 5 projects, some of them relatively involved. We're going to be cutting and marking and making a 20-foot truss. I will be showing everybody the round, square tubing wedge cut. That's been a highly anticipated feature. Okay, there's 4 parts in this card holder. All right, let's turn off the coolant. I'm going to go ahead and move the torch back. You can see the tube stabilizer or the lifter lifted. All right, let's pull our parts out. We got 1, 2, 3, 4, and there we go. What if you could see the ID in there virtually no slag. The cuts are absolutely beautiful. If you look on this here, I don't know if you'll be able to see it good. There are the markings that the welder is going to use in order to jig up this piece. That is our card holder 1¼ inch pipe pieces. Let's go ahead and load up the 3/4 inch tubing and we'll cut that. This is going to be our next piece that we cut, 3/4 OD. Let me go ahead and instead of just swapping everything out off camera, I kind of want to show you how easy it is. We're going to disengage the automatic stabilizer right here. All we need to do now is place the tube in. There we go. Okay. Lock it down. All righty. Let's go ahead and run it out here. What I need to do is lower the torch down. And we just want to place it inside of the end of the part. I'm a little bit outside. So let's go ahead and move her down a little bit more and then we'll move her in. Notice the lifter popped out of the way. It's fully automatic. We're looking pretty good right there. A little bit on the high side. I have to reset Y0 and tell the cutter that I now want you to start this program here, and we have to load up the new program. Remember, we generated 2 programs. We generated one for the 3/4 and one for the 3.15. We are literally ready to go. Let's go ahead. I'm going to engage the transfer balls. Let's hit the go button again. Oh, coolant. Let's get the cooling going. All right, here we go. Another thing you might notice is a very small amount of smoke being created. That's another advantage of cooling. Wow, that part's much, oh no, it is long. I thought it was a little on the small side. That cutout right there is where the other 3/4 tube is going to pass through this one. One down. Now you're seeing the tubing drop a little bit more lower than normal, and that's because I did not adjust the rear roller up to this tubing. I figured, what the heck, it's not going to matter anyway. All righty, let's turn off the coolant, move the torch out of the way, and let's take a look at our pieces. All right, there's the 2 3/4 pieces, and this is the one that, I mean, look at that fit. Come on, how cool is that? Anyway, let's go ahead now, take all of our pieces, and head over to the welding department. Hey, Chad. I got a job for you. This is one of my welders, Chad. You might recognize him if you watch, you know, the Most Wanted, 10 Most Wanted or something like that. But anyway, I need to weld this up. And the way it works is I have markers drawn on the tube that are going to match the tubes themselves. And let's see if we can put it all together, or would you like to walk in there and see a picture of it, you know? Anyway, you're going to line everything up. These here fit flat on the floor. So we'll fit like that. And then we have the others, so we have 3 of them, like this here. I believe this is the top, this is the one side. So this will be the left side right here, I think. Let's go look at the picture. Come on, I'm going to show you the picture. We're going to go look at the picture so I can show him what he's going to do. Okay, it turns out that this is actually a pretty cool piece. It goes together like one of those puzzles that you buy at the store. What we found out real quick is this is the top tube. We know about that. We've got the right side tube here because remember, all these legs have to lay down flat. So we figured out that we could come through here. And by the way, we haven't touched any of these with a grinder. This is the fit that we're getting. We are probably going to hit the outsides a little bit for looks. Now in the picture, he had the right side. Okay, I'm going to flip it around because he had the cope side going this way. So we'll do that. Now we have to run. This is the really cool one, the one with that funky slot I was telling you about. This one here is going to sit like this, and we're going to run this up through here, like that right there. Now, This is pretty darn cool. Hey Travis, if you're watching, he's the gentleman who sent me this. I really appreciate it. This is the cool part. So now we've got this. We've got these parts coming through like that, and we are going to remove that. We're going to place this one. Let's see if I get this right. All right, I'm here. Make sure I did this right. Whoops, my bad. Okay, yeah, this is good. All right, so we're here like that. Now, yeah, it's kind of confusing, guys. All right, if we look through it, let's see, we're going through here. Stay with it, Bob, stay with it. You can do this. All right, so that goes like that. This one goes up into this piece here. We rotate everything. We set it down. We can now take the top part, place it on the top here, line everything up, take a look at our markers, rotate it to wherever we need it to be. And believe it or not, okay, I think that's good, right? Move that up a little bit. And that, folks, is the business card holder before we weld it. So let's let Chad do his thing, and I'll show you the finished part. Well, there you go. That's our finished card holder right there. We got all the features that I wanted into it. Came out beautifully. Anyway, obviously this video was made in order to show you the machines cutting, but also show you how we create parts in our software Camelot. If you've got any suggestions or things that you might think could trick us up pretty good, go ahead and send them to support@jd2.com or even sales@jd2.com, and I'd be more than happy to look at it because I am actively looking for projects. My plan is to do as many project videos on our machinery. Now that includes wood routing, rotary cutting, flatbed cutting, things like that, as I can over the next couple of months. So any suggestions by y'all would be greatly appreciated. Anyway, if you want to see how this part was created, watch the second part of this video, and I will go step by step in our software and show you exactly how I created that part. Hope you have a great day. Really appreciate you watching. Goodbye. Okay. Hello again. In this video segment, I am going to show you how to use our software Camelot to recreate this business card holder that you see on your screen. A gentleman named Travis sent it to me. He already owns another manufacturer's machine and software, and he was curious as to see how our software and machine could reproduce this part. Now, I didn't get any specs or dimensions from him, other than the fact that the large tubing is 1.25 inches, the small tubing is 3/4, which means as I create this in Camelot, we're just winging it. We're going to make up numbers and try to get as close as we can to what we see here in the picture. Now, I'm not going to dwell on every feature in Camelot. However, I am going to explain some of the features to you so that you kind of understand what Camelot is all about and what we are doing with that software. If you were to snap your fingers and say, "Go, Bob," I could probably create this part in Camelot in under 5 minutes. However, we're going to spend a little bit more time than that showing you how to do it. Anyway, let's build this sucker. The first thing we're going to need to do is make sure that we have these 2 tubes in our profile library. So let's go check that. We'll click profile library over here, center that. All right, this is where Camelot stores all of the different materials that it works with, all your tube sizes, whether they be round, square, rectangular. Let's go ahead and sort by OD, and I can see that we have 2 entries for 3/4 inch tubing. One has a 120 wall and one has an 090 wall. Well, I went out there in our material racks and I found 3/4 120 wall, so we're good to go right there. However, I did not have any 1.25 inch tubing, but we did have 1 inch pipe, which is pretty close in size, a little bit larger. But if you look at the profile library, I do not have an entry for 1 inch pipe, so we're going to go ahead and create one. To do that, all you need to do is select any item on the list, come over here and modify the input boxes, and then save it, and then you have a new entry. So let's go ahead. And a lot of times I like to put the OD of the tubing in front of the description because it makes it easy for me to find it, because I typically think in numbers and not labels. So we're going to go ahead and say 1.315 inches. because that is what 1-inch pipe OD is. And then over here, I'm going to go ahead and put 1-inch schedule 40 pipe, and we'll put that in parentheses. Under material description, I am going to put steel. You don't have to. These are just descriptive fields that you can say whatever you want. Here, I will modify this to be 1.315, and the wall thickness of 1-inch schedule 40 pipe is 133. Now, we're not bending this tube, but I still want to fill out some of the fields. So I'm going to go ahead and put a lead in of 0.875, which typically is what the lead in is for the majority of our dies. The achieved center line radius, I have no idea, but I know we bend a lot of 1-inch pipe on a 3.5-inch center line radius. So let's go ahead and add an 1/8 inch for spring back, and we'll call this 3 5/8. K factor is how much the tubing is going to stretch when you bend it. Once again, we don't know what that factor is. If I went out and did the test, I could open up the K factor calculator and pretty easily determine that. However, a good rule of thumb is if you don't know, just put 0.5. Your K factor will almost always certainly be below that number. So if you pull up an entry and you see 0.5, it's a good hint that you have not actually determined the K factor of your tube. All right, we have a profile picture right here. All we have to do right now is hit the add button. Let's resort by OD, and there is our 1.315 entry right there. Let's go ahead, close, and make selective profile active. Let's bring back up our picture of the card holder and see if we can come up with some dimensions. A business card is 3.5 inches by 2 inches tall. So it looks like to me that this top tubing is maybe 5 inches long, something like that. And it looks like, I'm just guessing now, 4.5 inches from the center line of this tubing to the floor right here. So we'll use that number. I noticed the front columns are leaning rearward. So let's go ahead and say that the top tube is going to be 1.5 inches behind the center of the two front columns. And if you look at the rear column, it looks like to me it's got a little bit more angle than the front. So we'll say that it's going to be 2 inches behind the center line of this particular one right here. And then we have the other two tubes. We'll figure that once we get to that point. Let's go ahead and start entering these tubes into Camelot. Let's start by creating this top tube here in Camelot. I'm going to select Create Frame. A frame in Camelot is any kind of structure. It can only be one tube or it could be many tubes. It could also be a structure that you created maybe in Inventor, Fusion 360, SolidWorks, something like that, and then imported into Camelot, or you literally created in Camelot like what we're doing right here. If you look on the left side, you'll see that the active profile is the 1-inch pipe that we selected earlier. You could click this button and select another size, but right now we're pretty good to go right there. In order to start creating our frame, we are going to click Add New Tube. And over here on the right side are the input boxes where you'll be entering the coordinates telling Camelot where to place this tube in 3D space. So talking about 3D space, let me explain a little bit to you about the axes. In our world, we live in a 3D world. We have, in the CAD world, we refer to that as X, Y, Z. X, I'm walking to the right. X minus, I'm walking to the left. Y positive, I'm walking forward. Y minus, I'm walking back. Up and down, of course, pretty explanatory right there. So what you see here is the 0, 0 point of those three axes, which is entered over here. That is the default value that Camelot will put in there for you. Let me go ahead and use the mouse wheel. I'm going to zoom out a little bit. Now, I'm going to go ahead and make this structure symmetric, which means I'm going to be working both on the left and the right side of the Y0 axis or the X0 point. Let's go ahead and enter the top tube, the Z height, the distance above the floor, 4.5 inches, because that's what we said we could do earlier. Remember I mentioned we're going to lean it back 1.5 inches. So on the Y-axis, this axis right here, going rearward, we are going to type 1.5 inches. And then on the X, I am going to put minus 2.5 because that is half of 5 inches. Half is going to be on the negative side, half will be on the positive side. We now have our first point defined. Let's go ahead and tell Camelot now where to place the second point so that it could actually create this tube. Now I'm going to use another feature called relative in Camelot. And what absolute means, what we did on the first point, was in 3D space, I absolutely want you to place this point right here. Relative means from the point that I'm at right now, I want you to place the next point this distance along these axes. You could also place it at angles, things like that. That's a subject of another video. Check them out if you've got time. We are going to go relative in the X positive direction, 5 inches, because that's how long our tube is. And we now have our first tube has been created. Real quick, let me show you what the little view orientation box is doing up here. If I select this one, it says isometric view. It basically is going to look down at an angle on your structure or frame. The other ones, they're labeled. They will allow you to go to top view, for instance, left view, front view, etc. I'm going to go ahead and reselect ISO view for this particular application, what we're doing right here. All right. Let's go ahead now and enter reference points. To do that, we are going to select Add Reference Point on Part. However, all reference points are created from the previous point. So let's go ahead and select P1, which will move the red circle to the highlighted point, the active point. Hit Add Reference Point on Part. Now, if you notice, you've got a few choices down here that you can enter. By default, Camelot will place the point in the middle between the first point and the second point because that's a very common way to do it. A lot of people are joining to the middle for a lot of reasons. However, you could change that. We could say I only want it 25% over. We could do that. I could say I want it 25% over from the next point. So you saw it do that by me clicking this button here. In this particular system or particular frame we're making, we do want it in the middle, so let's leave it at 50%. Now, let's reselect P1, add another reference point. This time we are not going to do a percentage. We're going to unselect percentage, and we are going to enter an absolute number, 1 inch. You can see it has placed that point 1 inch from P1, the first point. Now, we're good right there. Let's go ahead and add another one. Now, this point here in the middle is the rear column connection point. This one right here is the left front column. We are now creating the right front column connection point. So this time, we are not going to do a percentage again. We are going to say 1 inch, but we do want this one to be measured from the right point because this is the right side column. Now we go ahead and close this tool, and we now have our top tube has been defined. Now it's time to go ahead and insert the columns. Let's bring the picture back up and take a look at it. And just eyeballing it, I'm going to guess that the center of the front columns is about 5 inches apart also. It looks like it's pretty even with that right there. So let's go with that. Remember we said we're going to offset this back one 2 inches behind that. Let's go ahead and add a new tube. This time, absolute position is going to be Y minus 2.5, half of that 5-inch number that we talked about. And we'll do that, and you can see it puts a red dot there. Now this time we're going to do something different. We're going to add a point, but we're going to drive this point by an existing point. Now those points can be physical points on a piece of hardware or tubing, or they could be a reference point, and we're going to use the reference points that we created earlier. So let's click Define or Driven by Point. Now you'll see a little rubber band bouncing around. Notice it's bouncing to the grid. If I unselect grid, snap down here, it won't do that anymore. I could just go ahead now and go right to a vertex and select it. So we're going to select that one for the front column. And then let's go ahead. Now what we need to do is if you look at this from a side view like this, you can see that this is our floor right here, our 0Z. Well, you can see that part of the tube is above the floor and part is below it. Well, we want this thing to sit flat on the floor. So what we need to do is extend this tube out a little bit. And that's where this box right here comes in. Let's make sure we're on the right one. We're going to be on this one. We're going to go to point 2 and we're going to, point 1. and we are going to extend it 1 inch. All right, now if I was to go back and look at that, you can see where now the entire tube is below the bottom of that floor, so that when we cut it off, we'll have a nice flat face on the bottom. Let's go back here. All righty, let's go ahead, click add another tube so we can do the right side tube. Now this time we're going to go 2.5 inches to the right, and we're going to add a point. We're going to drive it by that point there. Once again, we are going to need to go to 0.1 and extend it out that 1 inch. We've done that. Let's go ahead and add another tube. Now this time we're going to start from a driven point, that middle reference point that we created. Driven by point, we will select that right there. We will add a point. Now we know we're going to go to an absolute position. We want to go to the floor. We're going to go to 0, but I want to go in the Y direction. In other words, I want to go this direction, that 2 inches, that I had mentioned before. So let's go to here. Come here. We're going to go to 2 inches, and that's it right there. Now we are also going to need to extend it 1 inch below the floor. So we go ahead and close our tool. Now, if we look at the different views, you can see how all 3 tubes are intersecting our top tube, and they're all protruding below floor level. So that completes all of the entry of the 1 inch pipe tubes. Now we're going to go ahead and enter the 3/4 inch horizontal tube. So let's go select active profile, sort by OD, and I am going to pick the 0.75 OD, 3/4 inch, 120 wall. It's important to pick the correct wall thickness because when Camelot calculates the cutting path, it's pulling from tables that are based on the thickness of the metal. So we're going to go ahead, close, and make selected active profile or profile active. And you can see that it's set up over here. Let's go ahead and take a look at our picture again. Looks like to me that this tube is about halfway up the front columns, and it's also extending out, if I had to guess, I'd say 1.5 inches, and that's what we'll go with. So let's go ahead and add a new tube. Oh, I'm sorry, we're not going to add a new tube. We need to add our reference points in the front column so that we could base that tube on those reference points. So we're going to go to Edit Frame, and we are going to select this tube right here. We're going to add ourselves a reference point, and since I mentioned we want to go up halfway, we can leave everything the way it is right here. We're actually good to go. All right, so let's go ahead now and select this one over here, add a reference point. It put it up halfway also. We can now close the tool. Now we can go ahead and enter our 3/4 inch horizontal tube. Let's add a new tube. We're going to drive it by this point here. Add a new point. We're going to drive it by this point here, and there's our horizontal tube. Remember though, we want to extend it out 1.5 inch. Whoops, wrong tube, I'm sorry. Let's reselect that. We want to extend it out left and right 1.5 inches. Now let's go ahead and select the next point, and we're going to extend it out 1.5 inches. And that is our horizontal tube that we need installed. So the next tube is going to be that tube that's running from the right front column, this tube right here. So we're going to cut through this tube and we're going to go into that tube back there. Looks like to me it's about just below this tube right here. So that they don't actually intersect those two tubes. So let's go ahead and we're going to add ourselves a reference point. I'm going to select this one here, and we're going to add a reference point 25%, okay? And you know what? Let me see something here first. Let's go ahead and add a reference point to this rear tube right here, and we're going to put it in the middle as we've done before. So, I'm sorry, let me go back. Come on. All right, so we got a reference point right there. Let's go ahead and look at something here. I'm going to turn off the grid for a minute by going to Grid, Unselect Visible. Now, if I go like this, where I'm basically lining up the 2 points, it looks like to me that this tube right here is not going to intersect that tube there. Well, where's the fun of that? Let's go ahead and raise that point up right there so that it does intersect it. And we're going to go to that reference point here, and we're going to go to that one. It's up 25%. Let's kick it up 35%. This way I can almost guarantee, oh yeah, it's going to hit it. Makes it a little bit more interesting what we're doing right there. All right, let's go ahead and close that. Let's go back to tube, add a tube. This time, once again, we're going to drive it by a point. We will drive it by, let's rotate around. We're going to drive it by that point. Now, in order to rotate, I'm holding down my left mouse button and just moving the cursor around the screen. We're going to add a point, and we are going to drive it by this point here. Let's see what we got. Oh yeah, look at that. It's cutting right through the other tube. I'm loving it. Now, let's go ahead and extend it out also 1.5 inches. Let's take a look and see. Oh, I'm sorry, I did it again on the wrong tube. Let's go to here and extend it out 1.5 inches. Okay, there we go. And you know what? It doesn't look bad, does it? Let's take a look at it this way. Okay. I think we're looking pretty good right there. Let's go ahead and close this, apply and close. And oh yeah, I think we've done okay right there. That's our basic structure. So now we are going to go ahead and start creating these cuts. You can see where we've cut through on each side here. We have a vertical cope right there. And of course, we've cut through all of the tubes also. So let's go ahead and start on that. Let's return to Edit Tubes so that we could add a tube. We're going to go ahead and start with the 3/4 because it's already selected. Now, first thing I'm going to want to do is click on this tube right here, click on this point, and select Edit Frame. That's going to allow us to see the coordinates of that point. If you notice, X is over 2 inches. We don't care about that one. We do care about Y 0.75. How far is that point down our Y-axis? And it looks like we're 2¼ inches off of the floor. So we're going to use that to help us create this next tube. Let's add new tube. We want to start below this tube. So since we're at 2¼ let's start at like 1.5. It doesn't matter, just as long as we're below it. If we rotate around, you can see where the point's below it. Now we're going to move over on the X-axis, pretty good distance. Let's move over like 3 inches. I'm going to go ahead and look at this from the top view. All right, we're going to move over even further on the X-axis. Okay, there you go, right there. And then the Y-axis, we have to move up that 0.75. So we have that. Now we can go ahead and add a point. And this time, we're just going to go up Z relative. I want to go up, I don't know, 2 inches. It doesn't matter just as long as we cut through the other tube. Now, if we look at it, we are not intersecting this tube right here. So let's go to our top view. We will return to point 1. Remember, the second point is being driven by the first point. So if we move the first point, it'll kind of like move the second point along with it. We said 4 inches. Let's see what 3.5 looks like. Okay, you can see if I zoom in here, you can see where we've cut pretty much right through the center of the end of the tube. We don't want to do that because our machine and Camelot is going to normalize the cut because the torch is vertical. So it's actually going to be cutting vertical way back here because of the thickness of the material. We don't want to do that. So let's move to the right a little bit. And you know what? That doesn't look bad, does it? We're going to leave most of the thickness of the other tube. We're going to cut through here. Maybe we'll move over just a little bit for giggles. All right, now if we go back, yes, that looks good. We're going to be able to cope through that pretty good. And all we need to do now is go ahead and enter the top 2 tubes. So let's go ahead and start on that. All right, let's peek at that picture again. And we are going to create 2 tubes, as mentioned earlier, that are going to cut through this. Now, we're clearly above the center line of this, and we're going to be to the right a pretty good distance. So let's go ahead and select a new active profile. We're going to pick the large tube size, which is right here. We're going to make that active. Now we can go ahead and add ourselves a new tube. Remember, this tube here is 5 inches long. So let's add a new tube. And we're going to start at the height of that tube was 4.5, and we want to be above it a little bit. So let's go 4.75, and once again, we're just guessing. Remember that tube was also set back 1.5 inches on the y-axis. So we're going to do that. And then as far as X goes, let's see, about half of that tube. Let's go ahead and move over about 3¼ inches and take a look and see what we've got. All right, now we're going to go ahead and move this point to Y0, because remember, we're creating a tube to cut through the other tube, so we need to start outside of the boundary of that other tube. Let's go ahead and add a point. We're going to go relative up the Y-axis. Once again, we don't care how far, just as long as we cut through the entire tube. We'll go 3 inches, and yep. Now, let's go ahead and look at it from a front view. And as we had before, a situation where we're not cutting through the tube at all. So we need to move to the left, and we need to move down. So we'll pick point 1. Let's see. Let's go over, see what 3 inches looks like. I don't think that's going to be enough. Let's go down to 4.65. Let's go over to 2.75. All right, that looks like that might be a little bit too much. We're going to... Let's go to, I don't know, 8.5? Okay, that looks pretty nice right there. I think that's a good coat there. So let's take a look at it from an isometric view. And yeah, I like that a lot. Okay, so what we're going to do now is create the other tube on the other side, but we're going to go ahead and use another feature in Camelot called mirroring. Okay, if you look at the top ribbon up here, you'll see under Transform, you'll see an entry called Mirror Items. We are going to select the base point, or we could use the grid as the mirror plane. Look at other videos explaining this up here. Basically, you're just saying, hey, in this line, I want you to mirror across this line. However, for this application, since I've created it symmetric, there's an easier way to do that. Let's go ahead, select grid, and this time we're going to select a different grid. Now we need to make the grid visible so that you can see what I'm doing. We want to select that grid right there, which is cutting right through the middle of the part. Let me go ahead and hit ISO view. We're going to use that as our mirror plane. So now we need to select that we selected the grid, or we're going to use the grid as mirror. Now we need to select the items. We're going to pick this right here, and as you see it pop the new one over there, all we have to do is hit apply. Whoops. Let's hit Control Z. Control Z will undo, and I have to select copy items right here and then apply. Now we have both items. If I close the tool, let's go ahead and re-hide the grid. You could see where now we have both tubes. And what you saw there when I mirrored it, if I do not select copy items, what it does, it mirrors this tube to that side, but deletes this tube. So you saw what I just did right there. Okay, we have all of our structure entered. Now it's time to start chopping away at tubes here. Okay, I almost forgot one important feature. What good is a card holder if we don't actually put a slot in it in order to hold the card? So we do need one more item. What we're going to do is use the grid functions, and we are going to turn the grid on, but this time we are going to offset that. Well, first we need to select the XY grid. Now these grid planes right here are defined by the axis indicators. So an XY grid, for instance, you could see to where it's on the XY axis, that if I pick the YZ, it's going to be cutting across the YZ axis. So that's how that works there. We're going to want to go to our floor axis right here, and we're going to offset it up to the middle of the top tube. So we'll select grid offset, and we will type 4.5 inches. Now this is where the power of grids really shines. We need to create ourselves a rectangular object that we are going to subtract its volume from this top tube right here. So if you look at the picture one more time, I think I mentioned that a business card is 3.5 inches long. So we're going to make our slot 3.6 inches long, and we're going to make it about a 1/2 inch deep. So what we're going to do is we're going to use the grid to help us do that. Let's look at a top view right here. Now, what you're seeing these squares are, it's a grid step. So we have 1 inch on the x-axis, 1 inch on the y. So we basically have a 1 square inch grid. We're going to go ahead and change that because since I want to make a 1/2 inch wide slot, I am going to change the y step to 0.25 inches. And if I'm going to start at the middle of this tube, if I go up 1 grid step, that's 0.25 directions in that way, 0.25 this way, I have my 1/2 inch wide slot. Now, we are really going to cheat with the X because remember, we built this thing symmetric. So if I was now to say that the X grid step is half of 3.6 or 1.8, I now have a very easy way to create this rectangle that we're getting ready to do. All right, so let's go ahead now and we are going to go to geometry. Let's go ahead, get ourselves, oh no, we don't need isometric view. We're going to add a rectangular plane. Now, currently in Camelot, we need to select 2 grid points to create a plane. That will be changing shortly to where you can enter actual coordinates like we do with the tubes, create almost anything you want, almost any shape, profiles, things like that. However, we are going to select 2 points because it is July 10th, 2021, and we haven't implemented that coordinate entry system yet. Now, as soon as I click this button, select 2 points on grid, you see the red dot bouncing around. Here's our middle of our tube. All we have to do is go up a quarter, go over 1 grid step, hit that. Now we can go back over here to this one. You see in it drawing a phantom square. We click that. Now let's go back to ISO view and see what we've got right here because we're going to make the thickness of this plate 2 inches, okay? And what it did is it basically did what it said right here, mid-plane. It extended that 2 inches on both sides of that rectangle. If you go below it or above it, it will change the direction. We're going to select below it right there so that we're going to cut in that direction and we're going to apply it. We now have a square structure that we could use to subtract this one. So let's bounce back over to our tubes. Oh, I'm sorry. I'll go ahead and turn the grid off because it does make it a little bit easier to see everything. And actually, let's go ahead and apply and close. I'm going to go to tube, apply and close. All right, here's what we got right here. Red is telling you that it is reference geometry, and we have all our tubes in. Now we could start hacking away on all those other tubes. We're going to need to return to Edit Tubes mode. And what we're going to want to do is make certain items into helper geometry. Now, what helper geometry means is we're using that to help create our structure, but it's actually not part of the structure. Now, what we have on this particular deal is 4 pieces of geometry that are not going to be part of the final product. Let's go ahead. Now, if you look at helper geometry over here, it's saying mark or unmarked selected items as helper geometry. Now, if you notice, it's grayed out because we haven't selected any items. Let's go ahead and select this tube here. We're going to hold down the control key, select this tube, and that rectangle that we created. Now, if we go over to helper geometry, we can mark or unmark it. In this case, it's going to mark it. And if you noticed, if you could look at your screen real good, you could see the phantom outlines of the helper geometry. And that is what the function of helper geometry is. It's allow us to modify other parts using other geometry that isn't part of the structure. So now we can go ahead and actually start the cutting process a little bit easier. We could have started it with them shown, but I kind of like to see it with them kind of hidden because it shows the cuts a little bit better. Up on the ribbon bar, you've got a add or modify tube group. We're going to select cut tubes with a face because what we're going to do is we're going to go ahead and cut the 3 front columns even with the floor. So we're going to select shapes to cut, this one, and this one. And we're going to use the grid as the cut plane. So if I go back and I make the grid visible, let's make sure, well, we don't want to use that one, do we? We're going to want to reselect the grid from 4.5 inches above Z. We're going to reset the grid to the floor again. And right there. So there we go. Now we go ahead, leave that alone. I'm going to go ahead and change the steps back to 1 inch by 1 inch. That's a personal preference. It doesn't matter at all. All right, now if we go back to our tube, cut tubes, well, we're already in that mode, I'm sorry. Use grid as cut plane. We do that, and it's basically showing us a yellow arrow, and it says anything in that direction of the arrow, I'm going to whack off. So let's go ahead and hit cut 3 parts. And as you can see, let's hide the grid so you can see it a little bit easier. We now have our 3 columns have been cut flush with the floor, and it's time to move on to the next tubes. I'm going to point out to you something that only eagle eyes would have noticed, and it's the name in the tab up here, which is the open document. Now, if you notice, I've got card holder F12, and what I am doing as I am creating these video segments, I am saving them as I go along, and I'm incrementing my number F12, 13, 14, etc. I learned that lesson the hard way using SolidWorks, where I had to save a lot in order to back up if I had to, if it crashed or we had other issues. So that is one habit that I picked up that you may want to think about, because if I do make an irreversible move, I could just go back to a previous version that I made. And then once I've got the entire structure where I'm pretty much good to go, then I'm going to go ahead and delete all those other files and just stay with the same one. I just wanted to point that out there to you. If you bring your attention to the ribbon bar, you'll see Add or Modify Tube Group. We're going to select Cut Tubes. Now, Cut Tubes with a Face is going to cut all the tubes with a flat face that you may have created. Let's say, for instance, instead of using the grid as the floor and cutting the other tubes with it, I had gone in and created a square structure which had a face on it. I could have selected that face and cut with it. That's also very handy when situations where maybe you have created a flange plate in another program and you have imported it as geometry into Camelot using our DXF import function, you could select with face. However, we're not going to be doing that. We're going to be selecting cut tubes with other tubes, other structures. So let's select that. We're going to go ahead and start. It tells you right over here, select shapes to cut. We're going to start with the left tube because it's very easy to go ahead and select this object right here, cut with all others, and basically it's going to cut holes through it that any other structure intersects that tube with. So let's go ahead and hit apply. Takes a second. There's a lot of math going on here. All right, there you go. You can see where it's cut a hole on this tube here to go for that tube to go through, and we've coped the end. So that's pretty nice. Let's go ahead and look at the rear tube. We should be able to do the exact same thing to the rear tube. And it looks nice. We got our cut hole going through the middle right there. Let's go ahead and move our attention to this tube right here. And we are going to also want to cut with all others. A little bit more math going on there. Okay, if we rotate, oh yeah, that's what I was hoping we were going to see. Got a kind of a cool looking shape right there. It might be hard to see on the screen, but it looks like a figure 8. So when we cut this out on the rotary cutter out there, it's going to give us a pretty good looking piece. Let's go ahead now, unselect cut with all others, because we're now going to cut the top tube and we don't want to actually have these try to cut into it also. So we're going to select our cutting shapes and we're going to hold down the control key and select both tubes and that square item that we created earlier. Hit apply. All right, let's zoom in. You can see the square cut out there. We've coped both ends. We're good. Let's go ahead and cut this tube right here with our helper geometry there. That was very quick, very simple math there. All right, now we've got one other tube to cope, and it's actually this one right here. We want to cope it with that. And what I'm trying to do in my mind, I see a structure that has to go together in a particular order or you don't get it together. So I'm going to cope this tube so that we have to insert it first before inserting the other. Don't ask me why, I just want to do it. So let's go ahead and apply that. And now we are pretty much done. Let's go ahead and apply and close. Now we need to examine our structure, make sure we didn't make any mistakes at all. If we were to click on a tube, it's a little bit easier to see what the shapes are. In fact, if I zoom in, you see the white line right here? That is a cope mark. We have cut the tubing right there. Same by selecting this tube here, you can see the cope marks that we've placed into it. Okay, we are now ready to start processing this item. That's our finished item. You're looking at it. Let's go ahead and start making some G-code so we can go out to the machine and cut this thing out. I'm going to use a feature in Camelot to help the welders align this structure. Let's go back to Edit Tubes. And I'm going to select wire markers right here, and it's easier for me to just show you what it does. It says select target tube. We're going to select that one. Now we're going to select connected tubes. We're going to hold down the control key and select these three here. Let's zoom in. You see these yellow lines right here? I have three choices: outer contour, inner contour, or both. Now you may want to use an inner contour if you were doing something like maybe tapping a hole into another tube and you need to make sure that it was inside the diameter of another tube. And by marking it, it would allow you to see that easy. And that is indeed what we're doing right here. We're going to be placing marks on the tube using the magic marker that's on the machine out there to help the welders align these items. So I go ahead, I hit apply, and if you notice, we now have these black marks that will be drawn on the tube, not cut. They'll be drawn on the tube. And you can do this a lot to just basically help your guys align things or place positions where things need to happen. We are now going to create jobs, and inside jobs, Camelot will generate G-code. In other words, a job is going to define the profiles, the marks, everything that we need to do to our parts in order to make it. And once we have all that, then we'll be able to create G-code in that job and send it to our rotary cutters. Now we're going to need a job for every different kind and size of tubing. So we only have two in this. We have the 1-inch pipe and the 3/4 tube, but Camelot is basically going to go through and sort all of this out into individual sizes. So we have two ways of doing it. We could select a part or multiple parts and then click Make Job for Selected Parts, at which case Camelot is going to make a job for only those two parts there. That's what you would do is if, let's just say you had inventory and they came up and said, hey, Bob, we need more top tubes. Can you make me 10 of them? It would just make a job for that tube. However, in our application, we want to make the whole card holder. So let's go ahead, make job for all tubes. Now you see a progress bar down here. It's calculating all of the paths, all of the contour paths of all of the edges, the markings, everything that needs to be done so that we can start generating G-code from this part. Let's give it a second to finish. All right, it's asking us to save the job name. Now, what it's doing is basically it's going to create two jobs, small and large, so we're going to need two files. So let's go ahead and call this one Cal Card Holder 1. Okay. All right, now it's asking us for the second one. I'm just going to rename that one to 2. We now have both of our jobs up here listed like that. So Card Holder 1 job is clearly the large tube, and Card Holder job 2 is our small tube. So our next step is to add operations. Let me show you a couple of things about the viewports that you're seeing in front of you. Let's go ahead and start with the tabs. We have a tube view tab that if we go over here to the tube parts panel, we could select the individual tubes that are all of that particular size. If we go over here to nest view, we see nothing because we haven't created a nest yet. A nest is typically one or more parts that have been placed on a piece of tube that we're going to process so we could take it out to the machine and make that part. Part view will show you all of the parts of that size in the that you have in your structure. I could select these parts right here and it will highlight the corresponding one over here. And then if I wanted to see that part, let's just say this one here, I could return to tube view and there it is right there. Now, let's go ahead and talk about the layers here. When Camelot generated the geometry, it basically created two layers. On one layer, we place cuts, and these are typically what we're going to refer to like the ends of the tubing, things like that. The other layer, and by the way, the cuts layer would be this here. That's shown in cyan right there. If we look at the holes layer, Camelot looked at the part and said, you have holes in it. I'm going to put it on that particular layer, and that's what you're now seeing in cyan right there. So anyway, that's the overview of how to get around in Camelot looking at the individual parts. We are now going to need to go ahead and create operations on those items. To create an operation, let's go down here to the lower left and select the plus button. That will bring up our panel that we're going to be able to use to create the operation. Now, remember, we're going to want to cut the holes first, so I am going to select that layer, holes, because once again, if we cut the ends, tube falls out of the machine, can't cut the holes. If you notice up here in the right, Camelot looked at the thickness of the material, then it looked into the database supplied to us by the plasma cutter manufacturer and determined that the nearest entry to it was 0.135 inches. And we're dealing with 120 wall, so it selected those cut settings to use, and that's how it came up with the offset value for the torch. Now, the torch is being offset to the middle of the kerf that it's going to cut through your tube. The kerf is the slot that is actually being cut. Now, one thing we need to do is make sure we're telling Camelot the correct consumables that are in the machine. Right now, it has picked fine cut shielded because that's a very common consumable for that thickness of metal. However, we have already preloaded 45 amp shielded into the machine, so I'm going to select that. Now, you didn't really notice because I didn't point it out, but this changed the offset of the kerf to 0.0305. If I go back to fine shield, you'll see it that it goes to 0.0255 because a 45 amp shielded consumable is going to cut a wider slot through your tubing. Now, you know why fine cut is called fine cut. It's a smaller slot. Now, we're going to go ahead and pick inside offset, and we are going to, at this point in the presentation, we're going to tell it use half of the kerf width. As an offset, we're going to say okay. Now, if we zoom in, you can now see, you can see right here, see the dark gray? That's the actual outline of the part or the contour, and the cyan is what we are going to be cutting. Let's go up here. You can kind of see it. If I go ahead and click on it, move around a little bit. If I go right here, you can see the actual path that has been offset to the inside of the holes. That is our first operation. Now what we need to do is create the operation for the outside in cuts. So once again, let's go select the plus sign. We're going to do a cut operation on layer cuts. So we're going to cut the outside. We have everything is already set as it was before. However, we do need to reselect 45 amp shielded. Now I'm going to go ahead and point something out to you. Unfortunately, we're not perfect, and we are working very hard adding features to Camelot, and the features we're adding are structural shape profile cuts, such as angles, channels, things like that. And in the last few days, we broke Camelot in a very minor way. It's not a big deal, but we are aware of it. And I'm going to be honest with you. If we make a mistake, I'm going to show it to you. Good news is we write this software. We could therefore create the patch or fix it very, very quickly. And that's what they're going to be doing here in the next few days because I just pointed out the error to them. Anyway, if normally on a cut, we're going to want to cut on the outside of the profile, we would select outside offset. You could also select no offset if you wanted, and that would typically make your holes larger and the ends of your tubing or the length of your part shorter because we've cut farther into the tube. So let's go ahead with outside offset, and I will show you the bug that we created. If you look right here, the path has been offset to the inside
of the cut path. So what we need to do is return back to the layer cuts operation. I am going to right click and select edit, and temporarily I'm going to go ahead and make that an inside offset, even though really it's not. If you're looking at this beyond July 10th by any measurable days, you're not going to notice this bug, so you could disregard everything I said. Anyway, now if you notice, our path is to the outside of the tubing. Everything is hunky-dory once again. That's it. We've created the operations for that part. Let's go ahead and create the operations for the large part before we actually nest these. But before I do that, I am going to go ahead and save my work. Now we are on job 2, so I am going to save job 2 at this state in case something goes wrong. I'm going to go up here on my tabs, and I am going to select the large tube right here. You notice we have 4 of those tubes. We have quite a few of them. And we are going to go ahead and create operations for these. So let's hit the plus button. Now this time, if you notice over here, we have 3 layers. We have cam markers, and that is going to be the magic marker outline of the profiles that we created earlier, showing the welders where to place the columns. Then let me close this right here. Then we have, then we have holes, and then we have our outside cuts. We're going to want to do the cam markers first. Anyway, let's go ahead, hit the plus sign to add an operation, and I am going to select layer cam markers. But instead of the plasma cutting, we're going to tell it we want to use the marker tool. Now notice there's no kerf offsets because there's no kerf. Let's go ahead and select OK. We now have that operation. Let's go ahead and create an operation for our holes. And by the way, it's going to create this operation for all of the holes. So if you look at this tube right here, it's already created operations for our cam markers right there, or our profile marker. And we are going to be creating operations for holes in all of the parts. So let's go ahead and select plus under operations. We're going to pick holes, inside offset, and we're going to change our consumables to 45 amp shielded, and we're going to hit OK. Now, if we were to start looking at the different tubes and all, let's go to layer tubes. All right, bring up that whole layer. Alrighty. You can see the path has been offset to the inside of the part, which is absolutely correct. This is what we are trying to accomplish. You could clearly see it right there to where it's inside. So the holes are done. Everything looks real good. Let's go ahead and do the outside cuts. Once again, unfortunately, I am going to have to pick the wrong setting, inside offset instead of outside offset. Once again, that'll be fixed real quick. Let's hit 45 amp shielded and say OK. Alrighty, now if we zoom in, you could see the cut paths are on the right side of the part. Now, another thing I could point out to you is you're seeing a flat structure out here, and that's because I have show unfolding selected. If I unselect it, that goes away and you just see your part right there. In fact, you could very clearly see that the path has been offset to the outside right there. I like to work with show unfolding because it allows me to click out there and very easily select a layer. Alrighty, so we've got that done right there. And I am going to return to the picture, and I'm going to show you a modification we're going to make to these cut lines before we actually create this part. Let's pop our picture back up. Okay, we have tubes going through other tubes. Now we're dealing with plasma here, and lasers do this exact same thing, just not to the extent of a plasma cutter. And instead of cutting a perfectly sharp corner, there's going to be a slight angle. Now that angle is not the same all the way around a hole or around an end cut. It varies depending on what side of the plasma stream is actually being cut. So when we created these contours in Camelot, it basically created them as if it was a perfectly straight cut, which it clearly is not going to be. So what we're going to do is we are going to edit these contours in order to make the whole contours a little bit larger to help accommodate that taper. Also, since we are slipping a tube through another tube, we're going to want the holes to be a little bit larger anyway, to give us a little bit of clearance to slide these things through. So let's go ahead and let me show you how to edit the offset on a contour. I'm going to the lower left operations panel, and I am going to left click on layer holes, and then I'm going to right click and select edit. Now in the holes right here, if you notice under the contour offset path, we use half of the kerf width as the offset because that's what, you know, in a perfect world where we'd want to be. However, we're going to override that. We are going to go to manual contour offset. And instead of 30 thou offset, I'm going to go ahead and change that to 10 thou offset. But to show you what the effect of this is, let's go ahead first and change this to an absurdly large number, 0.2 inches. So we're going to move the middle of the torch over 0.2. I just want to clearly show you what's getting ready to happen. Let's go ahead and select OK. Now, look where the cut path has moved to. We are way inboard of the actual part. You could really see it up here. Let's go back to Layer Cuts, Edit. Let's go ahead, and what I'm going to do is I'm just going to click Use Half the Curve of Geometry because that will bring back my initial value. Now I can go into Manual, and I'm going to say instead of 30 thou offset, let's go with 10 thou offset. Go ahead and apply it. Now, once again, if we go look, you can see how much closer the offset path has been placed to it. Now, what we did right there is we did a global change. Any holes that are in that layer, regardless of the tube that we're working on, we have now applied that offset to it. That's pretty cool looking little shape, isn't it? We have applied that offset to it. So that's how you can globally alter a profile, an edit profile. Now, there is another way to do it to where you can do it individually. In order to do that, let's return to the 3/4 tube right here, and you can see where we have this cutout. And this cutout is where that horizontal tube, this one right here, is going to cut through this tube right there. So if I wanted to individually edit that contour, I would come up here under the contour group, select Edit Contours, and select the actual contour that I want to work with. Now, if you notice right here, I can alter a lot of things. I could change the start point of the offset, the end point, things like that. But for this particular video, and what we are concerned with here, is we are going to select override operation of this particular contour. Now, right now, this is the 3/4 tube. Remember, we only had one hole in both of those tubes, and it was in this one here. I'm going to go ahead and select this one to 0. 0. Okay, there we go. All righty, I'm going to override that. Now watch right here. You can see the offset of the contour, right? Watch what happens when I hit override. See it bounce out? We now are going to make that slot larger because when we slide that one tube up and then bring the other one in from the other direction, we just need a little more room. We don't need anything to be a tight fit. We want a little bit more room. So that is how you would override individual contours. The next step is to go ahead and create our nesting. Okay, up here on the ribbon bar, we have an item that we could select called Nest Tubes. Now, over here on the right side, we have a panel. Let's start off with the spacings. The front spacing is going to be how much extra material do we want to allow on the end of the program before we start cutting. Not necessarily the end of the tube, the end of the program, because let's just say we started this cut 12 inches in from the end of the tube and we entered a value there of 10 inches. We're actually going to move over 10 inches before we actually start cutting. So that's the front spacing. The mid spacing is the distance between the parts, and the back spacing is if you're cutting a number of parts that are going to be used or basically going to require multiple tubes, this is going to be the minimum amount of space that you want to leave between the last cut and the chuck that's rotating the part. Raw length right here, you can enter any number you want, but typically what it is the length of a piece of tubing that you have bought from your supplier in its raw state. Now, over here on the tube nestings, if I enter nothing, Camelot, when I go to create the nest, it will say, okay, how long is this part, this raw piece? I will use that, and I will put all of the parts on that part right there. However, what I did, my guys went ahead and cut me a piece of 3/4 tubing, 48 inches long, so I'm going to enter that. And now Camelot knows the length of the tube, and it's able to draw it on the screen with the chuck. If I entered nothing over here and I still wanted to cut on a 48-inch piece of tube, makes no difference. Camelot is going to generate this code, and it's going to start on whatever piece of tubing wherever you tell it to start. So no matter what length for this application, it would have made no difference at all. Now, let's go ahead and look at tube parts right here. Let's just say for this application, we're only building one card holder, so we're going to leave it at 1-1. Well, let's just say we were going to go ahead and build 10 card holders. We could easily change this to 10, and we could also change this to 10. But let's just say we already had 5 of those parts in stock, and we only wanted 5. So we do 5. Now, if we were to create our nest, we are going to make 15 parts, 10 and 5. Over here, we can override this. If we select this button here, override desired number, and let's just say we change this to 10 also, big number. If we now nest this tube, we are going to nest 15 parts here times 10. So this number here nests whatever we tell it to in this setting. In other words, it's going to nest the set. So that's one way to create a lot of parts in a hurry. I'm going to go ahead and set that back to 1 and not overwrite it. I am going to come back over here, double click, and I am going to select them back to 1 also, because once again, we're only building one card holder. Now, another thing I could have done is, let's just say I had cut this tube, but this tube here, I wanted a little bit more offset on that, about there piecing it together, and it turns out I could have done it a little bit differently. I want to make a change. I could select that one item, come over here, click, select only nested. When I hit nest tubes, you're only going to see that one part. However, once again, that's not what we're going to want to do. So let's go ahead and go back to our nest view and hit the nest tubes button. And there it is. There's our 2 tubes on the end of our piece of tube, and we are now ready to go ahead and generate code in order to create this part. But we do have one issue that I'm going to show you how to fix pretty quick. In order for Camelot to generate the G-code, and G-code is the language that CNC machines use to execute the operations, we're going to need to run the post processor up here in the left upper corner. It's going to ask us for a name to save the G-code. I've already entered card holder 0.75, so I know that I'm dealing with a 3/4 inch tube. So we'll select that, and here is all of the code that we will be placing that file onto our USB, taken out to the machine. Now, as soon as I ran the post processor, Camelot now has code to work with, and it knows what it's going to be doing, so we can animate the operation. Let's go ahead and do that, and I will show you the slight little issue that I was talking about. Now, this is not a bug. This is just the way Camelot generates code. Let's go ahead and hit animate. We cut the end. Now we're going to cut here. But what about the hole right there? Now we cut the hole, right? Well, unfortunately, the tube has already fallen out of the machine. Now, what we have in Camelot is a way to very easily fix this, and it's called contour ordering, and I'm going to need to switch screens to show you how to do that. First, I'm going to go ahead and close this right here because we're not going to need it. And we are going to go ahead and go to Tube View. We're back to the job now. We're going to go back to Tube View, and right here, we need to order these contours. So it's going to cut this one first, then this one, then that one. So let's go ahead and select Order Contours. And over here on a right panel, if I click on a contour, or I say select all, you could see the order that Camelot is going to process them. 1, 2, 3, obviously not what we want. We need to go ahead and select this contour here. I'm sorry, this one, and we're going to want to drag it above that one so that we now go 1, 2, 3 in that order, and that's all we have to do. We're pretty much got the problem fixed. Now, one thing we are doing in Camelot right now is we are making the ordering process more intelligent. So in the very near future, Camelot will give you options once you start nesting, and it will automatically do all this for you. That's in the very, very near future. So look out for that right there. All right, let's go back to nest this tube. Once again, we have to re-nest it. So we're going to remove all nestings right here because we want to create a new one. We are going to add our 48-inch length of tube back to it. And over here, we're just going to hit nest. All right, now if we run our post processor in order to generate our G code, we can now go back to animate, and look what happens this time. We cut the end, now the hole, and we're cutting in the correct order. So once we cut this part out, everything's going to be fine. Alrighty, so let's move on now and process the larger tube. I'm going to go ahead and reselect our 1-inch pipe job, and I'm going to go ahead and order these contours also because we now know that it really matters. So let's start off with tube 1 right here and select all. If we zoom in, we could see where we're cutting the end first, which is fine, no problem. We're cutting the slot, not really a problem. And then 3, big problem. We've just dropped the tube into the machine. Now, cutting the slot is also not a good idea yet because we have transfer balls in these machines, and depending on how long a slot may be, you may actually get into those transfer balls and they will lock the machine up and stop the whole operation. So what we're going to want to do is do these 3 markings first, then cut the slot, then cut the end. So if we select all, 1, 2, 3, that's not good. Let's go ahead one at a time. Let's hold down the left mouse button and drag these contours up into the order that we want. You see the red line up there? That's where I'm dragging them. So we now have the first operation, second, third. So we're marking. Now we're going to do the end cut, then the slot, then the other end, and we're looking pretty good. Let's go ahead and look at the other tubes. If I select all, I have 1, 2, 3, 4. Excellent. Go to the third tube. 1, 2, 3, 4. 5, there's actually an extra cut over there. Let's see what we've got. So we have 2 of these cuts right here. There's 3 holes. Let's go to the 4th one. Select all. 1, 2, 3. Excellent. Now, Camelot is already pretty smart at contouring ordering. It's going to do a lot of the work for you. What I was mentioning is we're trying to get to the point to where it's going to be smarter. It's going to look at, do I have marking operations? Do I want to do them first? And basically intelligently order all of the operations. So just as fast as you could click a button, you could head out to the machine and start cutting. That's what we're currently working on right now. So at this point, we can now go ahead and nest our large tube. Let's close this tool right here. And once again, we are going to go to our nesting group and select nest tubes. We're only making 1 card holder, so we'll leave everything alone right there. My guys, once again, they did cut me a piece of 48-inch piece of tube. Let's go ahead and hit the nest button. Alrighty, we now have all 4 of our parts right here. And we are currently working on another feature, literally at this exact moment, to where we want Camelot to be able to intelligently rotate parts and place them together so that we absolutely minimize the amount of tubing that we're using for a particular job. But we don't want to drag each individual part around and make you do it manually. We're working on making it fully automatic also, so once again, look for that in the future. We love what we're doing with Camelot. We've got an extensive roadmap of features that we're adding, and we're very excited about that. So, subscribe to the channel if you want, and you'll see these things as they pop up. Plus, I'm going to be doing a lot more projects. All right, now that we have a nesting, we can go ahead and run our processor. Once again, I will pick that file. Now that file, I named it 1.315 so that when I load up my material, it's very easy for me to determine what file I have to load up to tell the RC6 or whatever rotary cutter we're using out there to cut this. So that's why I did that. Let's go ahead and say okay. Here's our G code getting ready to pop up on the right side. There's quite a bit of it. Now we can go ahead and animate this one also. If we do want to do this, you don't have to animate, of course. If we zoom in, you can see that it's clearly marking the marks that we set for as a welding aid. And now it's going to go ahead and cut the ends and then the slot, etc., etc. All righty. Let's go ahead and zoom that out. All right, the next thing we need to do now is nothing more than take those two files that we created, place them onto a USB drive, and take them out to the machine and cut it. So let's do that. On the screen before you, we have the before and after. This is the picture that I was sent to duplicate, and this is what we actually made over here. Now, we have not powder coated or anything like that. We'd probably take the acetone, wipe off the markings, if we want to put it on our desk in its raw state. The video, as far as Camelot goes, took a little bit longer than I thought. It was about an hour and 8 minutes, but I did try to cover a lot of territory in a tutorial format. If I had to create this part on my own quickly, I would guess it's going to take me about 5 to 6 minutes to start creating it and then load it on the USB and head it out there to cut. Anyway, thank you very, very much for watching. Please subscribe for our other projects. I'm on a mission right here to do as many as I can over the next few months to show you what the machine will do. Once again, thank you very much for watching. I hope you have a great day. Goodbye.